Welcome back to another exciting episode of Cyber Defense TV. I'm your host, Gary Malevsky, and the publisher of Cyber Defense Magazine. Sitting in my hot seat today is a very special guest. It's Tomislav Perichin. He is one of the co-founders. He's also the chief software architect of one of my favorite companies, a Black Unicorn winner, ReversingLabs. Tomislav, welcome.
Thank you, and thank you very much for having me.
So I'm going to throw some fun acronyms at you today because I know you guys are up to something really incredible.
Yes.
What's an SBOM? What's an SBOM?
Oh, that is an awfully important term at this very particular point in time. So that stands for Software Bill of Materials, and it should be a household name by now, given it's been trying to be adopted by the industry for the last decade or so. But the whole idea behind it is very simple. For any given software package, you want to be able to give every single component which is present within it, ergo bill of materials. So you can say, this is what my software consists of. So you can know all of the ingredients that make up that piece of software.
So for years, programmers have been getting a degree in high school, learning a little bit of C++, hop into college, get their degree in computer science. Maybe they get a job in QA, work their way through college, get a little QA work, learn the basics, learn about source control, software dependencies, build processes, and the release image. But the one thing they forgot was Security 101. I haven't found any software security training courses yet, although we know there's a lot of free things for MITRE to teach us that common weakness enumeration, or whatever it's called, CWE, is a problem. Common vulnerabilities and exposure holes in our software, Swiss cheese, is a problem. What are you doing to help fix this? Because most developers don't get it.
Yeah, it's a very difficult problem. As you're saying, it is something that should start in college, right? As these guys are learning how to write code, you want them to have that security mindset as well, like not only making the application run and make it economic and deliver on time, but also try to make a secure piece of software that the users can actually trust. And we do believe in that. We need to educate the developers from early on, and we need to empower them with tools so they can actually monitor all these things, so they can secure the source code, so they can secure the final product, which is that release image as well.
ReversingLabs, I recently talked to your CEO about, your co-founder and CEO, Mario Folkson, about malware labs as a service, and big companies are getting malware, they don't understand it. And ultimately, malware exploits weaknesses, holes, backdoors, misconfigurations, and vulnerabilities that shouldn't be there because the supply chain management of writing code is messed up. You guys just launched a website called secure.software. There's no .com, it's secure.software. Tell us about this site. Tell us about how you inject yourselves in with all this threat intelligence you've built up over the years.
Yeah, it starts actually from analyzing the files themselves. So over the last decade or so that we've been building this company, we started by building an analytical engine, which tears apart any given binary to analyze it deeply. And one of the aspects that it detects is, is that application secure enough? So it looks at different components it uses to be built. It looks at vulnerability mitigation flags, for example. It looks at dependencies, all those things to tell you, what is this piece of code? And originally, obviously, it wasn't intended to just detect malicious software. But over the last couple of years, software supply chain attacks became really prevalent. And we learned quickly that the developers are now a target. They're an entry point into the organization. Either the attackers are trying to infect the organization the developer resides in, or its customer base. It quickly became apparent that there's no easy solution out there, so you can just plug in and scan any piece of software so you can get this assessment. Is this secure? What does it consist of? Are there any known vulnerabilities? Is it properly mitigating against things? Is it properly signed? Is it tampered with? All these important questions that we learned over the last couple of days, months, talking to different CISOs, like what are these things that you need to check when you deploy a piece of software? And that's exactly what secure.software is about.
So Tomislav, tell me a little more. If I'm developing my code and I'm in the development cycle where I'm already at release 1.0, I've got the image, Is it too late to inject your analysis? Because I've heard of things like, we'll secure your code with RASP, we'll wrap your code with magic, but that doesn't work. Are you looking at the source code, or are you looking at both source and binary? How do you do it?
Yeah, so our hypothesis is that, like, regardless of what happens on the source code side, the end result of building software is always something that you run, either a binary or a script or something compiled. And our idea is we need to be able to investigate the file as is just before deployment, so the exact same binary image. So that way you eliminate all sorts of tampering which could have occurred during building the product, and then just compiling all the things together. So if you look at it like that, then the only thing which makes sense to make sure that the image can be deployed is to actually investigate the compiled piece of code.
This is brilliant and sounds quickly and easily deployed. And I have so many questions, like, are you frequently updating? Does it matter where they've compiled, if it's Linux or Windows or Mac or Android or whatever? What platforms will you help us secure our code on? And is this kind of like the UL seal of approval for my toaster, so when I plug it in, it doesn't blow up?
Yeah, and that's the idea. Give us any piece of code that was compiled for any platform, and we will be able to analyze it. We're starting with this a decade worth of experience in analyzing malware code, and to solve that problem, continuously problem as well, we had to support all sorts of platforms. So Windows and Linux and mobile malware exists even today. So all these platforms we just add as modules to the platform. So as a remnant of that, any software package you give us. And the cool part is, like, software can be packaged in any number of ways. It can be installation packages, it can be ISO images, virtual machines. It doesn't really matter, right? As long as we support that as a format. We just plug it into the system, we recursively analyze it until there's no more components. And today we support more than 400 different file formats. All of the platforms you mentioned are already supported out of the box.
That's incredible. Now, let's say I'm building a next generation firewall or something. I'm building a security product, and I'm using hardened Linux, and I have to have a VM deployment. It's complex, but I've decided I'm going to use the latest OpenSSL for my TLS layer, and that happens to have a known vulnerability. Let's just pretend. Are you going to be able to notice that by looking at my VM and my whole system? Can you help me harden my firewall before I deploy it?
Absolutely, and we've just have helped a company recently with a similar scenario as you're describing. So this company had 22 virtual machines, so entire PC is obviously virtualized, which contains a specialized software. And we've scanned every single disk partition which was on it, found all the components embedded within those machines, Linux and Python dependencies, all of those things you get in a single pane of glass. And it literally tells you, these are your components in the bill of materials, here are the vulnerable ones. There was no malicious code in this particular case, but here's some sensitive data. Here's private keys, here's certificates. Here are all these vulnerability mitigation options which are not enabled properly across all of these machines, and here's digital signatures information. All of this as a single pane of glass. And we've delivered this report to a CISO who loved it. This is the level of confidence I need to ship software today. Because if you think about it, like SolarWinds just happened at that point, and there's all sorts of questions about every single software component. And deploying 22 virtual machines is hard and challenging by itself, but you need to know it's reasonably secure.
That's amazing. Are there any platforms or situations that you're not going to look at? What would you say, non-popular things, or an Android APK, or what, or an IPA for Apple, which I guess is not alcohol. It's
Yeah.
the executable, the IPA. It's not
a
beer.
It's not a beer, no. So those are supported. We are ramping up in certain areas where programming languages start to matter. One of the key parts of our technology is being able to describe through static analysis what's going to happen when you run the file. And for that to happen, anything which is natively compiled is generally fine, but things which could get compiled to bytecode or which are interpreted, they're right now being added. So for example, even though we do support .NET, Right now, we're adding support for Java and Python on the bytecode level. And those are really rapid efforts as our customers are deploying more and more of these types of applications.
It's very interesting. I've been told that hundreds of millions of websites are running WordPress, which is extremely vulnerable because of all the plugins that people deploy with it. So and I'm just curious if this would be a test, maybe some big bank decides to go off of the WordPress environment and they think they've written all the right code, added all the right security layers, but they've got 3 plugins that were third party. They don't even remember adding them to the library. This is, I believe, interpreted. It's PHP. It ends up being PHP. Will you be able to help harden WordPress solution?
That was a great question. Thank you. And I think you bring up a really good point, which comes down to how modern web applications are being developed. And we see this all the time, really. Modern web applications depend on this concept of software package repository. So NPM being one of the major ones being used. And here you have thousands of different dependencies, which are very easily installed. And software developers really don't even have the time or even in some cases capability to investigate these dependencies deeply. From the security standpoint, vulnerabilities, is this the right fit for my application at the end of the day becomes that question they're trying to answer. So on the web, it's a completely different set of rules. And that's exactly where we are right now trying to help people by defending them from software supply chain attacks. There's actually a blog coming up in a week or so about quite a few different issues that we found in NPM, which they're trying to target developers as means to entering the organizations. And as I'm saying, supply chain attacks, unfortunately, are going to become very common.
So Tomislav, over time, people are going to use your service not only to improve their software development, but maybe even to give the roadmap of the components being used to QA that maybe they weren't even sure were in there, and they might be surprised themselves. And maybe the QA team says, how come you've got this module, and do we have the rights to this module if it's open source? There's a lot of things people are going to find that they didn't expect to find running your system and totally improve the process. Like, oops, there's an extra wire in my toaster, and if it falls into the wrong spot, it's going to cause a fire, right? So UL is not going to pass. We're not going to pass muster. We're not going to get that certificate. So do you provide a seal of assurance that the code or the complete, binary or the deployment is good stuff in this current version based on running through your system?
Yeah, and that's exactly the point. We want to provide people with a really simple estimate. Is this quality or not? Or if it isn't a quality piece of software, where does it need to improve? And that's the important value. They digested it down to a grade. So you get a simple grade from A to F. But behind the grade, there's a whole bunch of checks that we do, actually hundreds of checks that you have to pass. And every single one of those checks comes with a severity, how difficult it is to remediate, and it has a grade by itself. So you kind of are driving developers to fix up the security of the entire application, regardless of how big it is, by pinpointing the most important parts first. And it really is rewarding. And I've been working with quite a few people over the last few months, just using this technology to see that security boundary being moved forward. All of a sudden now they are properly signing, everything's checked. They are doing reproducible builds. They are having all of these vulnerability mitigations enabled. And it is really a rewarding thing to see being put in action.
It sounds awesome. It reminds me of a Lego set, and you're examining every Lego saying, yeah, these pieces are going to fit together. Wait a minute. 3 of these Legos were not real. They were made in China. They're not the right spec. The whole thing's going to fall apart if you try to put these 3 pieces in. Go find the right components that actually fit.
You're absolutely right. And what happens a lot is these people realize, is this the right component for me? It does all these extra things. It has all these risks. Can I move to something else, which is less complicated, but more secure? And we've seen rapid reductions in code base sizes for quite a few of our clients, which just started tossing out redundant components, focusing on the key of what the library is supposed to be doing. So we had a client who dropped from 300,000 files in one release, like total, to 200,000. Like everything else was just extra. It's really incredible.
Yeah, and sometimes there's an accidental slip in of that Win32.hacktool file along in my jar file, programmer. So you actually can find all these things. You can tell me my software bill of materials, my SBOM, I've got 20% that doesn't look right or I don't even need, and 10% of that has the following CVEs, the following common vulnerabilities, exposures, or maybe even some other things that are not in the MITRE database.
Yeah, and I think the most important bit is how the static analysis actually works. It tells you about every single thing inside. People tend to be shocked, like when we start analyzing their installation package formats, for example. They tend to have a lot of different plugins which do a lot of different things, and they're not really secure. So you end up seeing components that you're seeing for the very first time as a relic of how you're building and that release image and how you're actually shipping it. All of that stuff is there. You just didn't know about it, and therefore it couldn't be on your software bill of materials if you were handcrafting it.
I noticed on the website, your new website, you also put pricing. So it's very
Yeah,
transparent and it
yeah,
looks pretty easy. Now, this is also a subscription service model, I assume, because I'm going to be recompiling and releasing version 2.1 and 2.2 or whatever my numbering scheme is. It sounds like Microsoft should run Windows through this before every release.
they have similar internal processes, let's put it like that. So yes, you're absolutely right. We do offer people to do one-off scans to establish the baseline. And I think the most important bit about that is this communication between us and the developer, focusing them on the most important bits, giving that advice and guiding them to improve practices. But there is an annual subscription model as well, which helps us do a couple of different things: monitor your progress over time, give you that stamp of approval for every single build, and then really you get these reports which are tracking the progress, so you can explain to yourself that the decisions you made have made you more secure.
So Reversing Labs really is an innovator, not only in threat, malware analysis, indicators of compromise, knowing 0-day better than anybody else, but now helping us by being the UL, the label of trust on any software that really shouldn't be deployed without a security analysis. And most coders are not, they don't even have security 101 in college campuses yet in the computer science departments.
Absolutely, that is the whole idea. We think about these attacks which happen, and even if you think about the latest one, like cassette software supply chain attack, it's a software supply chain attack which started as a vulnerability inside a product. If you secure the products, the attacks tend to reduce as well. So that's exactly what we're thinking. If we can help developers build more secure applications, the overall number of attacks gets lowered. And everything which unfortunately goes through, well, will be on the other end, so we can detect those, actual malicious payloads before they can do any harm.
So Tomislav, a tough question here in the hot seat. What about, let's just say, some weird buffer overflow problem? Some simple, I wrote the code wrong and I have a buffer overflow and now they're going to get root admin permission. Is that an obvious one for you to see with your solution? And how do you pinpoint it? Do you say line 37 of the code because you don't have the code in front of you? Or do you say there's a part of this binary that's bad?
So we're not at that level. So you wouldn't necessarily check out all of the SaaS tools to replace that with us. You would augment them at the very end and you would say, okay, I've done SaaS analysis. I've improved source code as much as source code could be improved. And at the very end, as I've compiled it, I'm just using secure software to make sure that everything's been compiled correctly. So we wouldn't necessarily be looking for buffer overflows, but we would be looking for vulnerability mitigation options and known vulnerabilities in your build. So you might be statically linking to something that wasn't accounted for, by an SCA tool that you already have. We will tell you about that. You might not enable all of the vulnerability mitigations. We will tell you about that. And we will also tell you if they are going to be effective or not. So we're looking at it as bridging that gap. What happens when you actually compile?
Yeah, sounds great. The tighter we can get our code, the more secure we can develop our apps. By the way, the thing that bothers me a lot lately is post-COVID, more than 51% are working from home. And so we are stressing the cloud more than ever. Everything's SaaS. People are just building apps left and right and rebuilding and retooling for a new environment where it used to be just a couple percent were working from home. This is a major shift in the risk profile. So it seems like everybody who's heading in that direction still needs to run through your new secure software offering.
Yeah, and you're right. Code is being developed outside the office now, right? You have that IT security in charge of even BYOD devices, right? You're taking that laptop home, you are programming on your own network where other devices are connected. You might be exposed to additional risks that IT security cannot account for right now. And if you're checking in code, that's a big problem.
So Tomislav, other than sending our viewers to secure.software, no.com, secure.software, and suggesting they click the analyze now, I would say everyone should do that. Did we miss anything? Is there anything else you want to share with our viewers and listeners?
Yeah, actually, we have a software supply chain roadshow as well. It's a virtual event. It's us talking to other potential interested parties in software security about all the problems that they are in managing and building software supply chain. It's also a drinking event to get your own wine and whiskey and all those types of things. So it's really fun. We've already done 2 of these, and there's still slots for a few more. So if you're interested, just give us a call and we can definitely host you on one of these events.
That sounds like a great event. And then again, your main website, your company, ReversingLabs.com, is really, we'll call it the parent of this process. You still do all these great things you do. In fact, the 10 plus years of this threat intelligence knowledge helped you build secure.software.
Exactly. Yes. So if you need threat intelligence, malware detection, malware lab deployments, large scale file analysis, we're there to help you. Yes.
My recommendation to our viewers and listeners is to not go it alone. And again, Tomislav Perchin is the chief software architect and co-founder of Reversing Labs. You have made it through my hot seat today. I really enjoyed this interview. Software is dear to my heart. I was writing code at 12 years old and I had no idea about security back then. And even computer science degree in college, we had no idea about security. But years later, I joined MITRE's CV advisory board, and boy, was that a wake-up call. And now we've got the MITRE ATT&CK and the CWE, and it's all about, like you say, the software, bill of materials, the supply chain management, not of building a jet, but the software used to design that jet might be extremely vulnerable like Swiss cheese without your help.
Yes. Thank you so much for having me today. This was a great discussion. I believe that people are going to realize this is a big problem and it's one worth solving.
Tomislav, thank you so much. Please say hello to Mario Folkson, one
Will
of my favorite CEOs. You guys are on the road to success. You are the black unicorn, thoroughbred racehorse moving in the right direction. So thank you again so much. And to our viewers and listeners, come back next time for another exciting episode of Cyber Defense TV.